Why study chemistry? Well, chemistry can help explain the natural world. All living and non living things are made of matter, so you're surrounded by chemistry. And having a better understanding about that can just help you better understand the world better. Chemistry can help you prepare for a career. You can major in chemistry in college, and lots of different fields require chemists in their work. Chemistry can make you a better informed citizen. Having more knowledge about the world around you just makes you a better citizen and have a better understanding about what's going on in your community. Chemistry has different effects on technology and society. It's responsible for many of the technologies that can benefit society, from the materials that we build things out of. We need chemists and chemicals to grow our agriculture. Chemistry has a big effect on the environment, energy, and medicine, and even the universe can be explained by chemistry. So first, let's talk about materials. Chemists don't just study matter, they make new kinds of matter. For example, plastics. These are all different plastics and with different formulas for different reasons. A kind of new field is concrete. Chemists can invent new kinds of concrete. So what we have on the top of this picture here by A is a control concrete. So it was cracked on day 0 and day 20. It's still kind of cracked. On the bottom, labeled B, is self-healing concrete. So it was cracked on day 0, and you can see by day 20, new concrete has been filled in. They can make concrete that's lighter, heavier, stronger, more durable for earthquakes. There's lots of different ways that you can improve upon the formula for concrete, and chemists are the ones that design this. Nanoparticles is a big field in chemistry recently. This is a nanotube. So this is a molecule of carbon, actually, that's wrapped around in a tube to make these little particles, these little tubes. And there's all sorts of applications for these in the future. They're supposedly really, really strong and very versatile. Glass. If you have a shatter-resistant glass cover on your cell phone, you can thank a chemist for designing that. They add boron to the glass recipe and make borosilicate glass, and all sorts of other kinds of interesting applications to glass chemistry. And semiconductors. Computers and cell phones run on increasingly faster and more powerful semiconductors that are all made of chemicals that we're going to learn about this year. Okay, our next field is agriculture. Chemists can help us increase the world's food supply. As the population of the planet is growing, we're going to need more and more food to feed these people. So they can apply the principles of chemistry to make the soil more productive and put chemicals back in that are being removed when the food is harvested. We can apply the principles of chemistry to the water that we use to grow our crops. Weed and insect prevention has to deal with chemistry. The chemicals that they make to kill insects or stop weeds from growing are all designed and invented by chemists. Some growth hormones are being added to certain types of fruits and vegetables to make them bigger and grow faster, specifically grapes. And chemists are doing genetic engineering to create disease-resistant plants to increase the yield of these plants to feed more people. Chemistry also has an effect on the environment, both good and bad. There are risks and benefits involved with discoveries in chemistry. So pollutants need to be identified and prevented. And chemists have a hand in both these things. So our first example is lead paint and lead gasoline. So a long time ago, they used to put lead in paint. This is a can of paint. You can see it says white lead. And it made the paint really bright and vibrant, specifically whites. But they were finding that as the lead got into houses and people were being exposed to this lead, there was all sorts of neurological symptoms that were popping up. And it needed to be identified by chemists. So the chemists were the ones who were responsible for figuring out that the lead, what was causing these problems. And then, of course, it needed to be prevented. They needed to pass laws to stop putting lead in things like paint and gasoline and invent new chemicals that will make the paint and the gasoline just as good. Here's an example of an old gas pump. You can see it says leaded. If you go today, it all says unleaded. This is a graph showing lead use over time. In the red, we see the lead paint steadily decrease since the early 1900s. And in the blue, we see the leaded gasoline. It goes up in the 70s, but as we were discovering that the lead was getting into the environment and causing all these problems, it was quickly outlawed and replaced with a new formula for gasoline. Ozone depletion is another example. So this is a picture showing the ozone layers measured in something called Dobson units from 1970s to the early 2000s. And you can see in the blue and purple, that means low Dobson units, not a lot of ozone. So over time, the ozone layer is getting weaker, specifically around the poles. It was identified by chemists. It took a long time for them to realize that it was a chemical called chlorofluorocarbons that was causing this problem. And it's been prevented by chemists inventing new chemicals that don't cause this damage. And the ozone layer is getting stronger, it's getting thicker, and by 2050, the story is that it's going to be as if there was never a hole in the ozone layer, so that's good. Global warming is another issue that chemists deal with. So this is the planet Earth, and around our planet and our atmosphere is a layer of what we call greenhouse gases. Water, methane, but specifically the most abundant in these greenhouse gases is carbon dioxide. As the sun's rays travel through space and through our atmosphere, they hit our planet and warm it up. They bounce around within that layer of the greenhouse gases, but eventually they find their way out. If this greenhouse gas layer gets thicker through the burning of fossil fuels, causing more and more carbon dioxide to be released into the atmosphere, what happens is the sun's energy stays within our atmosphere longer, and that makes the temperature heat up more and could increase melt the ice caps and increase the global temperatures. Chemistry also has a big impact on the field of energy. So due to the increasing global population, we have greater and greater demands for energy. So to meet these demands, we either have to conserve energy, use less of it, or find new sources of energy, like new sources of fossil fuels. So this is kind of controversial, but this is fracking. So in this picture, what it's showing is gas is being released from the shale layers down below, you see there, as water's pumped in and it fractures these shale layers, and natural gas that's trapped down there can come out. It's a great way to get a lot of what was previously unusable natural gas out that we can use. But there's also a lot of controversy around environmental pollution and things like this. And chemists have to try to solve those problems as well. We have solar energy as well. So this is a solar panel. It's filled with all sorts of chemicals off the periodic table that we're going to learn about later in the year. And it's a way of trapping energy from the sun and storing it in batteries to be used later. We also have wind. You can store energy in batteries by turning these wind turbines. And batteries. This is the Tesla battery farm in Australia. This is one big giant battery, and it's used for storing massive amounts of electricity that can power a lot of Australia. And there's going to be more applications to this in the future as it's getting better and better, and these batteries are getting smaller. And of course, nuclear. We'll be talking about nuclear chemistry later in the year. It's a way to make energy using a chemical reaction, a nuclear reaction. It has risks as well that we'll talk about, but it's also a fairly clean way compared to fossil fuels to get energy. Our next area we're going to talk about is medicine. So chemists supply materials that doctors use to treat patients, like vitamins and drugs. So vitamin C is found in citrus fruit, but we don't need to juice an orange every time we want to make vitamins. We know the chemical compounds that are in vitamin C, and we can synthesize them artificially in the lab. Same thing with penicillin. This is an antibiotic that's made from fungus, but there's not giant fungus farms that are growing penicillin for us. We know what the chemical compound for penicillin is, and again, we can synthesize it artificially in the lab. Same thing with aspirin. Chemists can design and invent materials for bone and joint transplants. So this is an artificial hip. It's made from metal alloys and plastic polymers, all designed by chemists. And artificial organs. This is a bladder. This is a bladder that's grown outside of the body using stem cells and artificial scaffolds, and they're getting better and better at making these artificial organs to treat people who have had to have them removed due to cancer and other things like that. Chemists are also genetically engineering bacteria that can produce human proteins. So if there's a protein that's particularly useful to humans, like say insulin, that we use to treat people who have diabetes, one way to get that insulin in large supplies is to genetically engineer it using biochemistry into bacteria. And then we can grow these bacteria in large enough numbers and harvest the insulin out of them to give to our patients with diabetes. And the last field we're going to talk about that chemistry has an impact is the universe. Chemistry can help gather data from space using special telescopes. On the right here, we have the Hubble Space Telescope, and it's soon to be replaced by the James Webb Space Telescope on the left, which is going to be even more powerful to look at planets and stars very, very far away. They can also analyze matter that's been brought back to Earth. This is a moon rock, and chemists can study the chemical composition of these things. We can study the composition of planets and other small space objects. So this is the Mars rover that's driving around on planet Mars, and they are learning things about water content and mineral makeup of the rocks and things like that using all the instrumentation on board. We can also study planet atmospheres and look at if there's possibility for life on other planets, if the atmosphere is conducive to life. Chemistry also explains us and our planet. So this is the sun. The sun is a large chemical reaction called fusion. We'll be talking about that later in the year. And all a fusion reaction is it's taking various forms of hydrogen and putting them together to make helium. And maybe deep in the core some smaller other elements. But eventually, in the sun's later stages of life, it explodes, goes what's called supernova, and it scatters all of those chemicals out into the universe. Before it explodes, it creates a really dense inner core that cooks those lighter elements into heavier ones. And those heavier elements travel all throughout the universe and condense into other solar systems. And all those ingredients for our planet Earth came from some exploded star elsewhere. And that's where all the atoms on the planet came from, and that's where you came from. You are made up of those atoms that were in your environment, and they originally came from a sun that exploded someplace else. So let's wrap things up here. So chemistry undoubtedly has an effect on your daily lives. You should understand why it's important for someone to have knowledge of this chemistry, as well as how chemistry affects other specific areas of research. I hope that makes sense, and if you have any questions, please let me know.